Hi everybody, in this video I'm going to show you how to do some limiting reactant problems and how to find excess and all that kind of stuff using BCA tables. I'm using the problems on page 10 of the guided notes packet. I highly encourage you to use BCA tables. I know that this is not what you would probably find on the internet, and it's probably not what you're going to find if you go to another chemistry teacher for help with this. I would like to show you just how easy using BCA tables makes doing these chemistry problems. All right. So anyway, why don't we start with the first one? Okay, so remember, whenever you're doing stoichiometry, you always must be working with moles because, remember, a number of moles is a number of counted things, right? And when we're doing stoichiometry, we care about the number of atoms and the number of molecules that are involved, okay? So always remember, you always must convert to moles if you're given grams. So what I've done here is I've converted the calcium carbide, the number of grams of calcium carbide, to a number of moles of calcium carbide, and the number of grams of water to moles of water. And now we're going to use this BCA table, which I've created. I am now going to put those mole values into the BCA table. Okay, so here's my BCA table. I put in the number of moles of calcium carbide and the number of moles of water that are given. Now, whenever you're given an amount of two reactants, you've got to find out which reactant is going to be the limiting reactant, because one of those reactants is going to run out first. So that's what the limiting reactant is. When we run out of the limiting reactant, the reaction stops. Okay, so the amount of stuff that we can make depends on the limiting reactant. So now we've got to decide which is our limiting reactant. All right, so I know that calcium carbide is going to be my limiting reactant. How do I know that? Because if I use up all of my calcium carbide, okay, I am going to need 2 times that number of water. Okay, so what I did here is I took 0.676 times 2, and I got this number. So now I would take the amount of water that's actually given minus the amount of water that's going to be used. Now, before I do that, let's just run through, how do I know that water is not the limiting reactant? Here it is, okay? If I was to use up all of this water, I would need about 0.9 moles of calcium carbide. I cannot take 0.9 moles away from 0.7 moles. That's basically what that is, 0.7. All right? So again, I know that I'm going to use up all of the calcium carbide. That leaves me with 0 amount of calcium carbide. Twice the amount of calcium carbide is how much I need of water. Why? Because that's a 1-to-2 ratio. I need, for every 1 mole of calcium carbide, I need 2 moles of water. So if I'm going to use this many moles of calcium carbide, I need 2 times that number for water. So let's see what this value is. If I subtract that, the amount of water that we need from the water that we have, I'll end up with 0.522 moles excess. I'm going to write that down now. That's excess water. We're going to have that left over. All right, now let's see how much product we're going to make. This is a balanced chemical equation. So for every 1 calcium carbide, I'm going to make 1 of these. It's called ethylene. No, it's acetylene, actually. This is called acetylene. All right, so for every 1 of these, I'm going to make 1 of these. And for every 1 of these, I'm going to make 1 of these. So what have we made, or what are we going to make? We're going to make, plus, we're making it 6, 7, 6, and 6. Whoops, back up. Sorry. 0.676. All right, so this is what we'll be making. We're going to make this much acetylene in moles and this much calcium hydroxide in moles. Okay, so we're going to be determining the mass. That's one of the questions we need to answer. What's the mass of calcium hydroxide? This is the number of moles. We'll find the mass. All right, determine the mass of acetylene produced. Okay, this is the number of moles of acetylene. We're going to see how many grams that is. We will. Identify the limiting reactant. We did that. It's calcium carbide. Identify the excess reactant. There we are. We identified it and determine the mass of the excess. Well, we're going to find out just how much 0.522 moles of water is. That's excess. Okay, I'm going to run these calculations and then I'll show them to you. All right, so here we have it. All the answers now are written out. We used the BCA table to find the limiting reactant. We found the excess in moles. We found the number of moles of acetylene that we can make. And we found the number of moles of calcium hydroxide that we could make. And all I did here was I converted everything to grams. So it's going to be 50 grams of calcium hydroxide, 17.6 grams of acetylene, and 9.4 grams of excess water. So that is everything that we need to do there. Let's try the next one. Okay, so here's the next problem. We're given a certain number of grams of hydrochloric acid, that's HCl, and a certain number of grams of sodium hydroxide. Aha! This is a typo. That's sodium hydroxide. Well, this is not sodium hydroxide. This is magnesium hydroxide. So we're going to go with the equation here, okay? I will change this. All right, so we're going to set up a BCA table. We're going to need to convert grams to moles first because we can't use the mole ratio until we've got moles, and then we'll solve the rest of it. So first step, here we go. Okay, so I converted the number of grams of HCl to the number of moles of HCl and the number of grams of magnesium hydroxide to the number of moles of magnesium hydroxide. Those numbers are now going to be put into the BCA table. Okay, I put these into the BCA table now. We have 0.214 moles of HCl, 0.09 moles of magnesium hydroxide, and of course, the reaction hasn't started yet, so we don't have any water or magnesium chloride yet, okay? I think it's pretty easy to see that magnesium hydroxide is going to be the limiting reactant. Why is that? If I use up all of it, I'm only going to need 2 times 0.09 is 0.18. So we're going to end up with 0.034 moles of HCl excess. So that makes, here I'm going to write this in red, magnesium hydroxide is our limiting reactant, and this is going to be excess. I'll just write X and S for excess. Okay. How much stuff are we going to make? Okay, let's take a look at that. So for every 2 HCl, I can make 2 waters. That means I'm going to make 0.180 moles of water. And I'm going to make 0.090 of the magnesium chloride, because it's a 2-to-2 ratio and a 1-to-1 ratio. So we pretty much solved everything. We just need to find mass now. So what's the mass of the water that's going to be produced? What is going to be the mass of the excess? That's all we really need to do. What have we answered already? Let's take a look at that. We've already identified B of this, of what we're trying to find. So this is B in our problem. Okay. And identify the excess. So they're just saying identify the excess. So technically that's what we've done. I'm going to highlight those now. So this is one of our answers. This is answer C. This is answer B. We still need to solve A and D because we just need to calculate the masses. So that's what we'll do right now. Okay, so everything is calculated here now. For A, we have 3.24 grams of water. That's how much we're going to make. For part D, we're going to have 1.241 grams of HCl excess, and our limiting reactant is magnesium hydroxide, and you can see the answer for C is HCl. That's the excess. Anyway, please just always be careful about units. Always read through the problem. What is the problem asking for? Just make sure that you're doing that. You notice that there were a lot of questions that could be asked about number 2, but all they really were asking for was, what is the limiting reactant? How much water can we make? And what is the excess of HCl that's going to be made? All right, so always be careful. All right, let's try another one. I mean, if you're feeling comfortable at this point, you could probably say, okay, I think I've seen enough. I'm going to go on and do another one if you feel like you could really use some extra help. Okay? Okay, first off, we're not given the equation, so I wrote out the equation based on what was said in the problem. I'm just basically following the words here. And of course, we always must balance. So we need a balanced equation, and there's the balanced equation. This is the amount of dinitrogen tetroxide that we're going to be given, and this is the amount of dinitrogen tetrahydride that will be given. Okay, anyway, don't worry about having to write out the equation on the test. The test is strictly going to be testing you on your ability to do stoichiometry. But here we are. We have the equation that we're going to use. Okay, I'm going to draw a BCA table and calculate moles, and then I'll be back. All right, so this is what we've got so far. I did the mole calculations there. So 0.045 moles of dinitrogen tetroxide, 0.65 moles of dinitrogen tetrahydride. Okay, boom, there we are. We've put the number of moles into our BCA table, and now we have to decide what is going to be the limiting reactant. So let's see. I think it's pretty obvious, honestly. I mean, when we're looking at this, um, okay, so if I was to use all of this 0.045 moles of this ingredient, I need 2 times that of the next of the N2H4. I need 2 times that number. So 2 times that number is 0.90. The answer is clear, which is going to be the limiting reactant. It's this one. Okay. All right. And we're going to end up with some excess. Okay, so we're going to have 0.56 moles excess of the N2H4. Okay, now how much nitrogen are we going to make and how much water are we going to make? Let's see. I'll tell you what, if we just look at what they're asking for here. So write the balanced equation, we did that. Determine the mass of nitrogen produced. Okay, we need to do that. Identify the limiting reactant, we already did that. Identify the excess reagent, we already did that. Determine the mass of the excess reagent. So we only need to find out the mass of nitrogen produced. In order to find out the number of moles of nitrogen produced, we're just going to take this amount of the N2O4 and multiply that by 3. Why? Because it's a 1:3 ratio. So let's see what 0.045 times 3 is. All right, so as far as the amount of nitrogen that we're going to make, it's 3 times 0.045. We get this number, 0.135. It wasn't asked for, but I just calculated it anyway. So in order to get the 0.180, I took the amount of N2H4 and multiplied it by 2. The ratio is 2 to 4. So the amount of water is twice that of the N2H4. So we've done all of our calculations and then some, except for the fact that I still need to find out what is the mass of this and the mass of that. All right, so there we have it. I calculated the mass of excess we have. There it is. Okay, the mass of excess. I calculated the mass of nitrogen produced. So that takes care of this problem number 3. I think that's enough for now, and maybe I'll make another video if anybody's really struggling with this. The more practice, the better. So I'll leave it at that.